Good morning, class. We're going to be covering 3.8 today, and this will be our last section before the test. Our test is on Friday. So before we begin, just a reminder, I will put a study guide up today, and at the end of the day, hopefully a practice test. The whole test will be divided into two parts. First part will be on Delta Math. The second part will be word problems on Google Forms. Okay, so we're going to be talking about 3.8 and rewriting formula equations and formulas. Now we need to know that a literal equation is going to be with coefficients that are letters. Okay. An example of this would be not written on that one because that's ax plus by equals c. Now notice that our letters here are our coefficients, what's normally in front, 2x plus 5y equals 6. Our coefficients, namely a, b, and c, are turned into letters. Now, solving for literal equations is quite simple as long as you keep things separated, so you don't combine things. And it's kind of like how we approach the numbers in a normal equation. So we're going to do ax plus b equals c. Now the idea is solve this for x. So we're going to approach it the same way, treating this in SADMAP, so we're going to subtract b from both sides. Now we can't combine anything because all of these are variables, but we can separate them. And then the next step is to divide both sides by a. And what this gives us is actually the template of how we normally solve equations, okay? So this is going to be our template for understanding how we solve it. Now, what if we had 2x plus 5 equals 11? So in this case, a equals 2, b equals 5, and c equals 11. So you're going to just plug this in. So c is 11, so x equals 11 minus b is 5, over a, which is 2. So x is going to equal 6 divided by 2, which is going to be 3. So our answer here is x equals 3. And simply put, we just substituted what we needed to do. Okay, that's what literal equations give us. Now let's look at some other examples of this very idea. So if you have variables in denominator, the key important note is variables in denominator cannot equal 0. Okay. Basically, just like our a there, when we had x equals c minus b over a could never be 0, okay? It cannot equal 0. That is just a part of it. The reason is because if we divide by 0 here, we don't get a meaningful statement, okay? It's something that is true in mathematics. It's possible to solve, but not necessary. So, let's try this one. Okay, solving it for x. We're going to subtract both sides by a first, getting negative bx equals c minus a. Now we're going to divide both sides by negative b, and in this case, that's going to be x equals, and if you have negative b, what you can do is put it to the front, or attach it to the top. So you get negative c minus a over b. The reason why I like to move it back to the top is I really prefer the bottom to be positive. Okay. So, what we'll end up getting, now remember, so we have 12 minus 5x equals negative 3. So a equals 12, negative b equals 5, negative 5. So that means b equals 5, and c equals negative 3. So plugging this in, we get x equals negative 3 minus 12, and this is all over positive 5. B, which you can't see here, so I'm going to write it over here. So x equals negative 3 minus 12. It's just plugging stuff in. Over, and then in this case, this was negative b. So then b equals 5. Okay, then solving this out, this becomes negative 15, positive 15, over 5 is x equals gonna equal 3. Okay, so our solution is x equals 3 using the process we just discussed. Okay, there will be a practice example that you can do on the Google form. Okay, continuing on. So 2 or more variables, it's the same exact process. If you're writing it, so if you have, in this case, 3x plus 2y equals 8, solving this for y as a function of x means x is on the other side. So of course we subtract by 3x, get 2y equals negative 3x plus 8. Now I order it from greatest power of x to least. And then we divide both sides by 2. Okay? And in this case, this becomes y, negative 3 over 2, x plus 4. Okay? Just simplifying. Okay? So this is a 2. Okay? This is also in the book. Now they do it in a different order, but that's not useful to us. So their ordering is not useful. Okay, what if we have equations where we need to solve for a different variable? This is actually quite useful. Okay, so pay close attention. If we have something, we have the area of a triangle, which is 1/2 base times height. Now you can write this in several ways, but this is the most commonly seen. What if we were trying to solve it for base, and we were given height and h, a height and area? What we need to do is first we can multiply both sides by 2. So we get 2a equals bh. Now if we're solving for b, we need to divide both sides by h. So we get 2a over h equals base. Okay, and you can do this any way to solve any variable equation. Okay? Now that's the crucial steps. Okay? And then there's one with Celsius and Fahrenheit. So this is just, let's look at Celsius Fahrenheit questions. And we're going to turn it from solving for Celsius to solving for Fahrenheit. Now some of you already know the formula, that's great. But the concept is what we're looking at. Okay? So concept is we're going to need to solve for f. So f by itself. Which means we need to multiply both sides. Multiply both sides by 9 over 5. So, sorry, that's going to look like 9 over 9. So 9 over 5. So these two cancel. So you get 9 over 5 c, and then no longer do you have parentheses, you have f minus 32. And given that, you just add 32 to both sides. And your answer is 9 over 5 c plus 32 equals f. Okay, and I'm going to rewrite it above because it's off the screen. Okay, my apologies. Actually, you want to do that. Okay? So, you can see 9 over 5c plus 32 equals f. So that takes us from solving for Celsius to solving for Fahrenheit. And actually, that's a great way of looking at how both of those equations relate to each other. Okay, actually on that note, some crucial Celsius and Fahrenheit things you should know is you should know negative 40 and negative 40, okay, are equal. Such as table I'll let you have. 0 and 32. And there's a few other ones. It's obviously 100 and 212. Okay. And then in this one, there's like room temperature, which depends on where you're at. I believe would be reasonable to say is around 22. Which one's a good one? 72? 32 makes sense. No, you divide by that. Yes, yeah, so 72 divided by. Nope, that won't work. Okay, well anyway, you can come up with two different ones. You know what, that will be part of the Google quiz. I want you to come up with a Celsius and a Fahrenheit conversion between 0 and 100. That gives you room temperature, so something normal that you would see, and something a little bit hotter. So maybe like the highest heat in a region. Okay? And that will be it for this video. We will have class shortly.